Hello guys, I'm Afra, your physics teacher. Today we have to start pressure. What is meant by pressure, and there are different terms that are related with the pressure. We will discuss each of these one by one. So let's start this. In this section we will learn about what is meant by pressure, examples of pressure in a liquid. And there are some formulas that are used to calculate the pressure. There are some example questions at the end of each section, and there are also some questions that you need to solve. First of all, what is meant by pressure? How you can define it? So pressure is basically represented by P. The pressure is defined as force per unit area acting on any object. If I consider this object, and this object has area A. Now if I apply any force on it, then this applied force per unit area is basically called as pressure. I can simply say that the pressure is defined as force acting per unit area of an object. When we have to see the unit of the pressure, as you know that pressure is equals to force per unit area, and force is measured in Newton, while the SI unit for the area is meter square. So pressure is measured in Newton per meter square. This is the SI unit for the pressure. So here the formula is given. Pressure is equals to force per unit area. The force is represented by F and the area is represented by A. And the pressure is represented by P. So P is equals to F over A. This formula is used to calculate the pressure if you know the values of the force and cross-section area. Here is also a triangular formula that is used to calculate the pressure. If I suppose that you want to calculate the pressure here, I write here P. It will be equals to, in this case you have to make the pressure as a subject and the force is appearing at the top. So there is F which is representing the force, and here the area is at the bottom. So force per unit area is basically called as pressure. This formula is used when you know the value of the force and area and you have to calculate the pressure. Next, if I suppose that you have to calculate the force, then make the force as a subject. Force would be equals to, as no, the pressure and area, both of these are appearing at the bottom. So you have to multiply both of these. There is pressure times area. If I say that you have to calculate the area, then in this case make the area as a subject. It would be equals to, the force is appearing at the top, so there is F, and the pressure is appearing at the bottom. Force per pressure is basically called as area. So I can simply say that if the two variables are given and you have to find out the unknown variable, you have to rearrange this triangular formula accordingly. The force is measured in Newton and the area is measured in meter square. According to that, when I write the pressure, which is force per unit area, as the force is measured in Newton and area is measured in meter square, so the unit for the pressure is Newton per meter square, which is basically the SI unit. And this Newton per meter square is basically called as Pascal. Both of these are the unit of the pressure. But Newton per meter square is the SI unit. Pascal is not SI unit of the pressure. Here the relation between the Pascal and Newton per meter square is given. So you can see here, a force is measured in Newton, area is measured in meter square. Therefore, pressure is measured in Newton per meter square, which is also be called as Pascal. And 1 Pascal is equals to 1 Newton per meter square. If I suppose that there are 10 Pascal pressure exerted by any object, then what would be this pressure in newtons per meter square? You have to tell me. Just here you need to make the conversion. Convert Pascal into Newton per meter square. Then what you get? 10 Pascal is equals to how many newtons per meter square? And according to the pressure, as we know, we have to consider any object and apply the force on that object. See that in which direction this force is applied on the object. Here you have to observe the angle between the object and the direction of the applied force. In this case, we have to consider the left side of that object and the force is applied here. So both of these making an angle of 90 degree with each other. It means that when you have to create the pressure, the force is always acting at right angle to the area. So as the force is always acting at right angle to the area should be the cross-sectional area of the object. It's not simple area, it's the cross-sectional area of the object. So I can simply say that when you have to produce the pressure, you need to apply the force at the right angle to surface, and here the area is the cross-sectional area. Next we have to see the relation between force and pressure. After that, the relation between the pressure and area. So let's consider the formula of the pressure. T is equals to F over area. According to this formula, the pressure is directly proportional to the force. When there is a direct relation between two quantities, it means that if one quantity increase, the other has to be increased. If the one quantity decrease, the other also decrease. So here if I suppose that force increases, then what will happen to the pressure? Of course the pressure increase because the pressure and force, both of these are directly proportional to each other. After that, if I suppose that the force acting on any object decrease, what would be the effect on the pressure? Either the pressure increase or decrease. You have to tell me. Next we have to see the relationship between the pressure and cross-section area. According to the formula of the pressure, P is inversely proportional to the area. When there is an inverse relationship between two quantities, it means that when you increase one quantity, the other will decrease. And by decreasing the one quantity, the other increase. Here if I suppose that the force is exerted over the large cross-sectional area, then what would be the effect on the pressure? Either it's a larger pressure or it's the smaller pressure. So see that force is exerted and this force is constant, it's not changing. It means next you have to see the relationship between the pressure and area. As the force is exerted on the large cross-sectional area, the cross-sectional area is larger, then accordingly the pressure would be small. By increasing the cross-sectional area, the pressure goes on decreasing. Both of these are inversely proportional to each other. So I can simply say that a force exerted across a larger cross-sectional area will produce the smaller force because the force and area, both of these are inversely proportional to each other. If I suppose that this force is basically exerted on smaller cross-sectional area, then what would be the effect on the pressure? Either this pressure increases or decreases. You have to answer me. Here is a question for you. First of all, here is the object and its cross-sectional area is A. You apply the force on that object whose magnitude is F. After that, I increases the cross-sectional area of that object. In this case, the cross-sectional area becomes 3 times. The new area is 3A and you apply the force on this object which is 1/3 of the previous force. So what would be the effect on the pressure by increasing the area and by decreasing the force? By how many factors the pressure increase or decrease? You have to answer me for that question, that what would be the effect on the pressure. You can see it's given here. Since the force always acts at right angle, it means that angle is 90 degree to this area. The area should always be the cross-sectional area of the object. A force exerted across a large area. When the force is exerted on the large area, according to the relationship between the pressure and area, by increasing the area, the pressure would decrease. It will produce the small pressure. Because the cross-sectional area is large, of course the pressure would be small. If the force is spread out across the small area, if the cross-sectional area is small, it will exert a large pressure. So, if the cross-sectional area is small, the pressure exerted would be large because the cross-sectional area and pressure, both of these are inversely proportional to each other.